So now we're looking at a paper from 2021, Pure 1 Maths, full paper from October, November. And our first question is to do with transformations. So y is equal to f of x, and we have a transformation to y is equal to 3 minus f of x. So we have two transformations. We have to put them in the correct order. The first one is a reflection. Reflection in the x-axis, which means it's parallel to the y-axis. And our second one is translation. So plus 3. So on a column vector, you'll see it here as 0 in the x direction and 3 up in the y-axis. Might as well draw a little picture. It could also have been a stretch, scale factor minus 1. You do the translation first. Either way, there's the transformation there. So reflection first, and then the translation. Second question, we're looking at the binomial expansion. So 1 plus a of x, in brackets all to the power of 6. So doing that out is pretty straightforward. You know your formula. Of course, you'll have ascending and descending parts. Ax squared. Make sure that last bit is all squared, and you can put in that power of 1 there just to make it clear if you want, dot dot. So you'll end up 1 plus 6ax plus 15 a squared x squared. That's part A. We have to now look at the coefficient of x squared for an expansion, and we're also given that it's equal to minus 3. And find the possible values of a. Okay, so 1 minus 3 of x times what we were given before. So 1 plus 6 ax plus 15 ax squared x squared. So from here you're going to put together any combinations that you will achieve an x squared with. So look at our first term. We've got 1, and of course that's going to go with our 15a squared x squared. So 1 times x squared is x squared in that context. And our second one there, our second term, is minus 3x, and we've our 6ax, because of course x times x is x squared. So that's what that means in terms of this question, and it's a very common question. So put them together and you'll get 15a squared minus 18a and then we have our answer as well. So equals minus 3 or plus 3, of course, as I've written. And of course we can hopefully factorize. If you cannot factorize, you'll always use either complete the square or the quadratic formula. So our answer is 1/5, a is 1/5, and a is 1. That's question 2 completed. Alrighty, question 3. Let's have a look. So we're looking at an expression. We've expressed y. So we've got, complete the square. And we've got functions as well. So let's complete the square here. And we're going to just simplify first. So factorize out of 5. So 5 bracket y squared minus 6y, close bracket plus 50. And we'll end up with a plus 5, I believe. Because our 5 times 9 is 45. So 5 bracket y minus 3 close bracket squared minus 45 plus 50. So our constant at the end will be 5. That's straightforward enough. So just make sure you look at the in the form part. Make sure there's no extra brackets around the outer edge, so that our b is in fact free of brackets, as we said. Okay. Part B is increasing or decreasing, so we're differentiating here. So when we've differentiated, we can compare back, like in terms of questions you're given. You know, you might say hence. In this case, it doesn't quite say, but it's part B of a question, and part A is directly linked. So we'll have kind of double bracket multiplication. You could call it that if you want. So we'll have 5 bracket x squared minus 3 close bracket squared plus 5, which is very close, very similar, but not the same to our original answer in 3a. But just looking at this here, if you multiply out using your FOIL method or whatever, double brackets, you'll see that that would be the same thing. So 5 times x to the power 4, 5 times minus 6, and 5 times 9. So it's the same in that context. So our f prime x squared is greater than 0. And of course, when it's greater than 0, it's increasing. You could also use the discriminant for this. So for when you find a derivative, we've minus 30 squared, which is 900. 900 is less than 4 times 5 times 50. And of course, that works out. 900 is less than 1000. Okay, question 4. We're looking at an arithmetic progression. So let's write out our little statements. You're always having to create little formulae here, little equations. So that is equal to 84. That's what we're given. Find the smallest value of it, of n, for where it's negative. So I'll rewrite that a little bit now. So A is equal to, is probably the easiest way to do it. A is equal to 84 minus 3, bracket n minus 1 close bracket. You can just start multiplying things up. You can actually just do it as a bit of guesswork. 3 times what? 3 times 30 is 90. So just thinking about it, 3 times, let's say 28. 3 times 28 is 84. Okay, that was just coincidental. I'm doing it in my head. But if n was 29, so you just think about it. So if n is 30, then you're going to have 3 times 29, where you're actually going to have your first negative number for the n term. So that makes sense. So n is 30. And we had to do it some kind of way there. We had 2 unknowns, a and n. You can't factorize. You can't find that. There's no simultaneous equation either. It's given that the sum of the first 2 k terms of that progression is equal to the sum of the first k terms. So using your formula, n over 2, 2a plus n minus 1d, for the sum of an arithmetic progression, just plug in those numbers, as I'm doing there. And to make the 2 statements equal to each other, well, statements as in what's given, so 2k terms is going to replace n. And our a was 84, and our difference, our d, was minus 3. So we put that in there. From there, just simplify down. So 2k over 2, we can make that k actually. I'll do it in the next step. 168, only for a bracket, minus 6k plus 3. Yeah, that's right. Is equal to k over 2, and the same thing here, but just minus 3k. 168 minus 3k plus 3. Okay, and simplifying it down again, the k in front. K times 171 minus 6k, I'll just turn that around, is equal to k times minus 3k plus 171 as well. And from there you can multiply everything out. So 2k times minus 6k is going to be done out. I'm going to get rid of that 2 actually as well there. So it's 2k. 2k times all of that, and no change. I'll just rewrite it all now. So that multiplication out, you'll get minus 12k squared plus 342 my head is doing it before I write it. Organize. Okay, minus 12k squared plus 342k is equal to minus 3k times k is k squared plus 171k. And you'll get 342 minus 171. So 9k squared is 171k. Cancel out your k's, and you get a nice whole number then. So how many 9s fit into 171? 19. That's your final answer. That's question 4. Okay, question 5. Often with these kind of questions with circular measure or radians. I'm going to draw this. You can see it B, X, and C. I'm going to draw that top half, we'd say. The red is the kind of the YC, you see there. Now that is a part of a circle. It's a quarter of a circle. And we have a point that's given, the BX is 9 in length. That's a radius. So we can already find something there. So XB is equal to XC. Just keep that in mind if you can see it. You're kind of splitting up the picture in your mind a little bit. Okay, same for the next one. So we have an arc. You'll see that YAC. So YA is the same as YC. And we also have that X line in there as well, which is in a way designed to put you off, perhaps. So showing that the angle XYC is equal to what's given there is actually not that much work. Just once you recognize these two facts here. So it's a little trigonometric sine calculation, because you'll have, just draw it here, you have 11 there on the hypotenuse and 9 on the opposite. So of course inverse of sine is 9 over 11, which is 0.9582. That's correct. Part B, find the diameter. What did I say? Diameter? No, find the perimeter. Find the perimeter. Okay, 2 arcs, and there are bits and pieces. Ah, that's okay. So we have the adjacent, well, yeah, the other side there, XY we call it. So XY, you can do that through using a Pythagorean theorem. So you end up with root 40. And then for YB and AX, so for YB, that length there, we were going to take away our root 40 from 9. So 9 minus root 40. And then, of course, the other one will be 11. 11 minus root 40. You can simplify there as I'm doing if you want. And AX is equal to 11 minus root 40. Or root 40 is 2 root 10. Same difference. You get 20 minus 2 root 10, which can be simplified as 13.68. And that's 1/3 of the way if you want. And we have 2 arcs. We have AC and we have BC as an arc. So using the AYC 0.9582, you can multiply that by 11, and that'll give you the AC arc. And then also we have, as I said at the beginning, a quarter circle. So 1/2 pi or pi over 2 times 9. So the pink part there if you want. So 9 times pi over 2 is 14.13716. And so at the end you can simplify that a little bit. 13.68 plus 10.54 plus 14 times 1/4 if you want is equal to 38.4 units. That's the perimeter for ABC. Okay, now we're looking at question 6, and we've got a sketch, and we have to sketch the inverse of y equals f of x. So along the y equals x line, in that direction, as opposed to the other way, as you might see usually, and there's an approximation. I'm just using my hand here, so it's not perfect, but you would do it much better in an exam, of course, with your pencil. That's part A. Part B is we're giving a function of minus x over root 4 minus x squared, and we have limits of minus 2 to 2. Find an expression for the inverse. So we're going to rearrange it. You could rearrange y equals x, or switch them around if you want at the beginning, or you can do it at the end. I'll leave it till the end. So starting off, we have y squared is equal to minus x over 4 minus x squared, and you can multiply across then. So think of y squared all over 1, so you'll multiply both of them across, and you'll end up with, for simplification, you can square in clear fractions, and we can deal with the negative at the end if you want. We'll have a negative at the end. So 4 of y squared equals x squared minus x squared and y squared. You can move the x squared and y squared over, so we end up with x squared there, and we can then divide 1 plus y squared on both sides, and so you end up with x squared only, and then from there x is equal to root of all that, and it's plus or minus, of course, being a root, but we already stated that we had a negative. So 4y squared, of course, the root will cancel out the square, and 4 becomes 2. So we end up with 2y all over root 1 plus y squared. And again, change it at the end. You must make sure this is changed because it's an inverse function. So if you don't do it at the beginning, we have our answer of minus 2 of x all over root 1 plus x squared. That's your final answer. Make sure that negative is in there too. Go back over that if you want. I suppose it's a couple of steps. You could do it in your own style. You know that you can do it in a number of steps, as I said, but you can start off with the actual inverse done already or not. Okay, we have a few more questions on this. So if g of x is 2x for the parameter of minus a to a, find a maximum possible value. So we're looking for a positive value there for fg. Okay, so fg, let's have a look. So minus 2x, right, so we plug in 2x into whatever we have for x. So we'll end up with minus 2x, minus 2x over root 4 minus 2x squared, which will be 4x squared. So I'll simplify that now as well. So minus 2x over root 4 minus 4x squared. If you were to put in a number, let's just check 1. If you put in 1, negative root of 1, that will work. Can it be negative 1? Because it's a square, you see. So it's possible, but it asked us only for a maximum value. So the answer is 1. So fg of x, the max value for a is 1. Okay. And we have the last part here, part D, 6D. Assuming that fg can be found or formed, find and simplify. So we're simplifying what we have there. So minus 2x all over root 4 minus 4x squared. Well, we have both of our terms on the denominator include a 4. So we can factorize that out. So of course, if you find a root of 4, it'll be 2. And we can simplify accordingly. Let me just put that in there. So 4 minus 4x squared. So that's what we have. So keeping the same denominator, minus 2x. The common, of course, term is 2. So 2 times root 1 minus x squared. And of course you can cancel out the 2's. The two 2's outside that. So that'll be minus x all over root 1 minus x squared. That's the final answer. You could also, of course, more elaboratively, you can get rid of your square on the denominator by rationalizing the denominator. Let's have a look at that. 1 minus x squared for both of them. And when you've multiplied that out, you'll be able to cancel the top and bottom part. So minus x root 1 minus x squared over 1 minus x squared. And you'll see that, of course, on the top and the bottom, 1 and 11 will cancel out. So actually, if you multiply out 1, so root 1 times root 1, is 1. You'll see that they cancel out anyway. That's what happens when you rationalize the denominator. It gets rid of the root, the surd. Question 7. Okay, so we're looking at a trig identity. So we've got tan x plus cosine x. We'll multiply across first of all. So on the denominator, tan x minus cosine x times k. K is a constant, thank God. And our answer, we want a number of terms with sine. So we're going to try and transform everything into that, aren't we? So of course, using our two trig identities of tan x is equal to sine x over cosine x, and from there, I think you'll see with this next part, we'll just multiply across cosine x times cosine x is cosine squared x, so that sine of x is on its own there. And we can do that for both of them. So of course, from there, because we've cosine squared x, that is equal to 1 minus sine squared x. That's the other identity. So we've used both of our grade 11 or pure 1 math identities. And after that, probably a little bit of simplification. We're just basically trying to bring it towards k plus 1 times sine squared x plus k minus 1 times sine x minus k plus 1 equals 0. Not too much more manipulation, to be honest. Once you've done that, it's okay. So bringing everything on one side is important. So bringing, as you can see from the yellow parts, we want to put our sine square x together and our sine of x together, and anything else will go at the end with the k plus 1. So we'll end up with k sine squared x plus one of them plus sine squared x. So you can see that it's already coming to form. Then k sine x minus sine x. So you can see that coming to fruition too. And then lastly, we have just left over a minus k and a minus 1 when you bring it over or cancel on both sides. So that's the end of it, really. If you think about it, just factorizing out, you'll get k plus 1 of sine squared x plus k minus 1 of sine x. And lastly is k, and then of course it's going to be plus 1 because it's a negative outside the bracket. That's part A for question 7. Okay, next bit. Hence, so we're using what we have, or something from the answer of the previous question, previous part of the question, to solve this one. So all of that was equal to 4, and we're given a parameter range as well. In terms of our sine graph, we'll say, or the unit circle. So if you put that together, k plus 1, k minus 1, you'll have 5 sine x squared plus 3 sine x minus 5 is equal to 0. Can we factorize? I don't think so. So we'll use our quadratic formula. Minus 3 plus or minus root 3 squared is 9, minus 4 times 5 times minus 5 is 100, and over 10. 2 times 5 is 10. And from there, you'll get your calculator to do the work for you. And x is equal to 48. 48.1, we'll say. You should know, well, shoulda, woulda, coulda. You should know something, but let's not just pretend. You draw your graph, or use your unit circle, or just remind yourself that sine, in terms of like where a second part would be 180 minus. That's the way to remember it, or just draw your graph and you'll see it anyway. So 148 from 180 is 131.9. So there's your two answers for that. Question 8. A lot of detail here. We've a curve and a little curve on top of it. Let's just put in our values for x. So there are parameters. There will be limits when we're doing this integration question. It's an area of the region between the curves, so that's how I know it's integrated. And so we're going to have our elongated summation, with a 4 and a 4 and a quarter, 1/4, and then we put this together. So the one above is the 5/2 minus x to the power of a half, and then we subtract from that minus x to the minus a half. Close bracket, d of x, of course. So top to bottom. Alright, let's actually do this out. So 5/2, when we integrate that, will become 5/2x, and the rest of it here, just make sure you're adding 1 to the exponent, and that part is being put below for the next part as well. Okay, so just cancel out the parts there as well and put in our parameters. So we minus 2/3 x to the 3/2 minus 2x to the half, and again do that same thing. So when you plug in, substitute in x is 4 and x is 1/4, we're going to get our answer for the area of the region. So you get 10, 5/2 times 4. 2/3 of a quarter is 16/3, and minus 4. And the same for the last, or second part. 1/4 would be 5/8, minus 1/12, and then 2 times a half is 1, so minus 1. And get the calculator out. The last part is 7/9. 1 and 1/8. So 9/8. Okay, that's your answer for that one. So we integrated and found the area between those two curves. The normal, okay, the normal of the curve is perpendicular to the tangent. We're going to be differentiating generally when you use this. We've got our curve as y is equal to x to the minus a half. We're given a point 1, 1. It intersects, so of course if it intersects the y-axis you'll have 0. I don't need to point it out, just leave that off. So 0 and p, find the value of p. So y will be p in that context. So differentiating, you'll get x to the minus a half minus 1, so minus a half out front. So minus a half out front, let me just make sure, I'll put all the details there. So minus a half minus 1 minus a half in the front side. So minus a half x to the minus 3/2. And next we go, when x is equal to 1, because we're given a set of points, we get minus a half times 1 to the minus 3/2, which is of course minus a half. And that's the gradient. So the normal, so a perpendicular reciprocal, we call reciprocal, sorry. So the normal gradient will be 2. Okay, so plug that back in then to a new equation of the line. We have the points 1 and 1. Y minus 1 is equal to 2 times x minus 1. And of course, when x is equal to 0, y is equal to p. We have that already. And so p is equal to minus 1. Well, y is equal to minus 1 in this context. So of course p is 2. So the value of p is minus 1. And that should be clear enough there on that. And finding that value. Do we have a part C? No. So we've got question 9. Second to last question. We're given another bit of coordinate geometry. We've got a circle. X squared plus y squared equals 20. And let's plug in our parts. So we've got y equals. Let's plug that in and multiply it all out. So we'll end up with x squared plus 4x squared plus 20x plus 25 is equal to 20. You can move your minus 20 or cancel minus 20 on that side. So you'll end up with 5x squared plus 20x plus 5 is equal to 0. And of course that's all divisible by 5. So x squared plus 4x plus 1 is equal to 0. Definitely cannot factorize there. So complete square or quadratic formula. We'll just use the quadratic formula. So 16 minus 4/2. And so it's going to be a third base one. So yeah, we got minus 2. So x is equal to minus 2 plus root 3 or minus root 3. And that's x. So sub that back into one of them. Sub it back into the simplest equation that we have. So y is equal to 2x plus 5 So 2 times minus 2 plus or minus root 3, close bracket, plus 5, and you'll find your y values, which are 1 plus or minus 2 root 3. I can write them separately there just to make sure you understand us to them. So between the coordinates for A and B, in third form, we have minus 2 plus root 3, and we have 1 plus 2 root 3, and same for B with the negative part at the bottom on the denominator. And so hence find the exact length of the chord AB. So we're going to look at our length of the line formula. x2, well, it's the second x minus the first one, in brackets, plus y2 minus y1. And again, squaring those two as well. Just derived from the Pythagorean idea that you had earlier. Okay, putting that all together, it's definitely a bit longer than the line I've created. Put another one there maybe. There we go. You get 48 and 12, so the answer is root 60. That's an exact answer, so just remembering that when it says exact length, we're using thirds. Okay, the exact length. That's question 9a. Now we have a second part to this, so we're given a second part. Let me have a look. A straight line through the point 10 and 0 with gradient m is a tangent to it, so it's a tangent. So we're going to use our circle is x squared plus y squared equals 20. Let's plug in what we said for y there. So let's find that first. So y minus 0, that's the y value there, is equal to mx minus 10. Simplify that a little bit, you just got 0 basically, taken out of it, plus y. So put in your y there, so m times x minus 10 all squared. So it should be m squared x minus 10 squared is equal to 20. And from there you can multiply it out. So of course, x minus 10 squared is x squared minus 20x plus 100. And then simplify, and bring it down as much as you can. So m squared times x squared, 20x times m squared, 100 m squared. I'm going to change, I could change the 100 m squared to 20 as well. You want to get the same, you want to factorize as much as possible. So we have our squares, you know, we're going to use b squared minus 4ac. If we can. I think we can, yep. So x squared, I've got 1 plus, so I've got one of them plus x squared times m squared, and 100 m squared. So 100 m squared could also be 20 times 5m squared minus, we have a minus 20 as well. So I'm just trying to see, we can do it both ways, which is the easiest way. Let's put it together. We've got minus 20, so that's 400, so we have 400 m squared anyway. And then 4 times 1 plus m squared, let's say times our 20 times 5m squared, and then our minus 20, which is now minus 1 because we've factorized it out with our 20. So 4 times 20 is 80, and we just put that together a bit easier there. If you can just watch that step. I've multiplied the first b squared we call, and then I've simplified out the two terms of 4 and 20. So 400 m to the power of 4, and to be honest, if you look at it, 80 times 5 is also 400. So we're going to have 400 m to the power of 4 and minus 400 m to the power of 4, which is going to cancel out, if you know what I mean. Just remember 80 times 4m squared and 80 times minus 1 as well. So minus 80, so minus 320 m squared equals 80, or minus 80 equals 0. And so our m squared is equal to a quarter, 1 over 4. So m is equal to plus or minus, this is going to be root, it's plus or minus a half. So the possible values, it asks us for possible values of m. So we have two values of either a positive or a negative value of 1/2. And our very last question, the curve that we're given. And we have x is our variable, of course. find the f of prime again. Okay, let's differentiate it. So if you subtract, so we got minus 2 minus 1 is minus 3, so minus, and then our chain rule, so just be careful here as well, a half, so we should end up with minus 2, so minus, just minus 1, minus bracket a half x plus k to the power of minus 3. The other term at the back there, we don't have a variable of x, so it just disappears. And I've just written out the second derivative, d squared y over dx squared. I don't really need that yet, but anyway, just it would lead to the minimum. So we have the minimum like greater than 0. And so if you just plug in 2, for instance, you'll see we've got minus, so a half times 2 is 1, 1 plus k to minus 3 is greater than 0. So k is less than minus 1. And that's possible value. It says values, but in this case it's actually just one value for k. And that's about it for that question. So the minimum for x is like, we were given was x is equal to 2, so we plug that in there. So half times 2 is now given that k is actually equal to another number, so minus 3. And the minimum is given, so find that. So f of x, we're going to integrate here the original thing we were given. So we were given f prime of x. We were given the derivative. So let's integrate that now to find f of x. So we were given in brackets half x plus k to the minus 2 minus brackets 1 plus k to the minus 2. That's for part B. Part C is where we're going to use the second derivative as well. But let's just focus on B now. So half x minus 3 to the minus 2 minus, and I can plug in again the k, so 1 minus 3 is minus 2. Minus 2 there. So minus 2, is that right? Yeah. So, yep. And dx, or a little dx at the end always. So when you integrate, you'll get minus 2 plus 1, so you'll have minus 1 in the base. So we're going to have a different sign there as well, and also the chain rule, you multiply by a half. And then for the second one, we've minus a quarter x, or x over 4 if you want. And that's my minus 1 down there. Yes, that's minus 2. So y is equal to minus 2 times a half x minus 3, which is in brackets to the power of minus 1, and then minus x over 4. And from there we can plug in our values. So we were given a minimum for x is 2 and y is 3.5. So 3.5, 3.5 is equal to minus 2 bracket, a half times 2 minus 3, close bracket, to the minus 1, minus 2 over 4 plus c. Now I haven't put in plus c yet. I just wanted to leave that for this next part, but you always have it there when you've integrated. I'll just put it in green. So 3.5 is equal to 1. 2 over 4 is a half, so 1 minus a half plus c. Bring that over, you get 4, so c is equal to 3. So you can do the whole thing there if you want. You can rewrite it as well, making it more of a fractional form. So minus 2 all over 1 half x minus 3. There's no exponent. So minus 1 just brings that down as a denominator. And then just minus x over 4 plus 3. That's f of x, or y. And last part of the last question, other stationary point and the nature of it. So the nature of it is always asking you in terms of whether it's a minimum or maximum, and using the second derivative to see that directional thing. So what do we have? 1 half x minus 3 to the minus 2 minus, we were given a point, so minus 2, and we put in a minus 2 because that was 1 plus k, wasn't it? So just put in that again. And of course, that's going to be like 1/4. So we end up with a half x minus 3 to the minus 2 equals a quarter. Let's like invert that, we call it, in a way. So half x minus 3 to the power of 2 is equal to 4. You want to just make it as easy as possible. That's one great way of doing it. So then just cancel your powers on both, your square on both sides. So half x is equal to 5, so x is equal to 10. So from there, plug that back into the original. So y equals, so you've already integrated it. So minus 2 over half times 10 minus 3. And then separately, your second term is minus 10 over 4. And then lastly was c plus 3 that we got earlier. So y is equal to minus 1 minus 2.5 plus 3. And plug that together, you get y is equal to minus a half. So your two coordinates there for your stationary, your other stationary point are 10 for x and minus a half for y. And then lastly, just with the second derivative, plug in 10 just to check its nature. So you get minus. So f prime of x, 10 in this case. Let's plug it in. So to see the nature, minus 1/2 times 10 minus 3 in your brackets to the power of minus 3. And so you'll end up with, minus at the front as well there. So, yeah, minus half, so half times 10 is 5. So minus 5 minus 3, 5 minus 3 is going to be minus 2 anyway. So it's definitely going to be less than 0. Just look at the exponent as well. So if it's less than 0 on the second derivative, you're going to have a maximum.